Hello and welcome to my channel. I'm Master Ramizi and you're watching Maniac. So in today's video, we shall talk about astronomy and telescopes. Now telescopes are the most essential and crucial invention for astronomy. But although astronomy does not depend completely on telescopes, because telescopes were invented only in the 1600s, while people were observing the sky and experimenting with it for more than thousands of years, way before telescopes or even any other sky observing tools were invented. Astronomy began thousands of years ago in different parts of the world. At the time, humans started shaping civilizations and formed villages and cities. They got busier during the day, and at night, since there was no PlayStation or TV or radio to play with, they looked up in the heavens and thought about it. Now who these people were or how they did it, we don't know exactly for sure, but we do know that some ancient civilizations were very good at astronomy. For example, the Mayans, the ancient Egyptians, and the Mesopotamians were very good at astronomy. But the true nature of astronomy and sky observation began during the Golden Age of Islam, around 6th century AD, during which Europe was deep into the Dark Ages. Why? Because the Church and the Pope had full authority and control all over the Europe, and therefore any ideas or inventions against the teachings of the Church was considered to be punishable by death. However, in the Middle East, astronomers, scientists, and philosophers began rising one after the other, mainly translating the scriptures of Ptolemy, Archimedes, and Aristotle from Latin to Arabic. During this time, astronomers like Ibn al-Haytham was most popular for their inventions and discoveries, like the sextant or astrolabes. Now these tools were used before telescopes, or mathematics or geometry. During 14th century, uprisings began in Europe and was to continue until 17th century AD. Now this period of time is known to historians as the Renaissance. Although there is still doubt on who first invented the telescope, but we do know for sure that the first patent was in 1608 by Hans Lippershey, a Dutch-German spectacle maker. But the improved and much better version of the telescope came in 1 year after the invention in 1609 by, well, you guessed it, Galileo Galilei. Galileo made a 3 times more powerful telescope than the one Hans made and used it to discover the 4 moons of Jupiter, rings of Saturn, and many other astronomical bodies in space. But his greatest contributions doesn't just end with the telescope. Galileo did so many stuff that he's sometimes called the father of the modern science, father of astronomy, or father of science in general. And he deserves a video on his own, so stay tuned for that. During this period, he was able to prove the heliocentric model wrong. Now before him, people thought that the Earth was center of the universe, and everything around us was just revolving around us, because it made sense. The sun came up and set down, the moon showed up and set down. They were all revolving around us. That's what it looked like. So therefore everyone thought that the Earth is stationary. However, he proved this wrong. Later on, Galileo was accused of charges he didn't commit, and he was punished to death by the Church. Meanwhile, after the Renaissance, we saw science and technology skyrocketed. We saw great minds being born one after the other and solving the mysteries of the cosmos. But one of the most important achievements of science and astronomy came in the 1900s by a very respected man and a great man of science, Carl Sagan. Astronomy, like many other sciences, was considered to be for the old fellas in white coats and goggles. But Carl Sagan proved this wrong. He opened astronomy for everyone, as a part-time job, as a hobby, and as a fun, just like our ancestors used to have thousands of years ago. And soon we saw businesses opening in the field of astronomy. More and more people became interested, and a high demand for quality telescopes and sky observation materials. Soon enough, we can say astronomy became everybody's hobby. Aside from age, gender, occupation, or economy, everyone loved it. But not only for themselves, they also wanted to share the astronomy and word of peace with other people around the world and around their local areas. So people started gathering around in astronomy clubs in schools, in cities, in major metropolitan areas, or just sidewalk astronomy. Now, one of the examples of these clubs or initiatives is AAA, or Afghanistan Astronomy Association, which is the only astronomy initiative working in Afghanistan, and I'm proud to be part of it. Now back to our topic of telescopes. Telescopes were first invented for the purpose of stargazing and watching distant objects in sea and land, just like its predecessors like the sextant, octant, or astrolabe. Now at first, telescopes came in the very simplest and cheapest form, the refractor telescope. However, after years of research in the fields of optics and lens making by great scientists like Sir Isaac Newton, we were able to discover two more new types of telescopes, the reflector and the casquet. But first of all, let's talk about what telescopes are. A telescope is a device consisting of lens, mirror, or a combination of both to magnify and sharpen images that cannot be seen by naked eye. Telescopes come in all shapes and sizes, but currently we only use 6 types around the world, which we'll discuss in a minute. Now, first and foremost is the visible light telescope. Now, as the name suggests, these telescopes are commonly used between amateur astronomers, astronomy clubs, or even space agencies such as NASA or ESA uses them. Now, these telescopes see the visible part of the spectrum, the light rays, which you can use to detect, galaxies, planets, or very close stars, and they are used frequently around the world. Now, the second type are radio telescopes. Radio telescopes are huge, very, very huge, and only science institutions like NASA or ESA uses them, and they're very expensive.
As the name suggests, they scan the sky for radio bursts. Radio waves are also part of the electromagnetic spectrum, right next to microwaves. The radio wave is by far the longest wave we have discovered, which means it has got a lower frequency and therefore it's used everywhere, from mobile phones to computers to Wi-Fi. The radio wave is also emitted from bodies outside the solar system, and this is what a radio telescope looks like.
Microwave is next to the radio waves in the electromagnetic spectrum, and just like radio wave, it's invisible to naked eye. However, we can see the world in microwave.
Ever since the Big Bang, some 300,000 years later, the universe cooled and let light flow through it. After 13 billion years, space itself stretched these visible light waves to a shorter and shorter frequency, ending up with microwave. If you had a big microwave telescope and scanned the sky with it, it would look like this.
Next is infrared telescopes. Now, just as other waves, we cannot see it. However, we can feel it. Just step outside into the sun and you feel the warmth of the sun. That is infrared.
Stars pump huge amounts of this invisible light, and using special telescopes, we can detect and study them.
X-ray telescopes.
Now, X-ray telescopes are the toughest telescopes around because they scan the skies for X-ray bursts, which mainly happen in near event horizons of black holes or neutron stars. Now, these telescopes scan the skies for these objects and maps them out.
Gamma ray telescopes.
Gamma rays by far are the most energetic and high-frequency waves in the electromagnetic spectrum, which makes them lethal. In high doses, gamma rays can be fatal to humans, but due to the atmosphere of Earth, we are protected. So, most of the telescopes scanning for gamma rays are outside the atmosphere and space. Now, these telescopes can scan the sky for dying stars, neutrino bursts, or supernova, which would produce huge amounts of gamma rays.
Now, each and every single one of these telescope types have their own unique ability, and has proven many scientific theories and has given us enough information about the universe. However, today we are specifically talking about the visible light ray telescope. Now these telescopes come in all shapes and sizes and apertures. Aperture is the diameter of the primary lens or mirror. But there are three main telescopes in this section. Refracting telescopes or refractors are simple to use telescopes which uses lenses to focus and magnify images for human eyes to see. Now these telescopes are fairly easy to use and much cheaper than any other types of telescopes in the market today. Reflecting telescope. This telescope uses mirrors to reflect, magnify and focus images of stars, planets and the moon. Now these telescopes mainly have two mirrors, one primary which is a relatively big one and a secondary which is a relatively smaller one, which uses to focus and magnify the images. These telescopes come in different apertures and sizes starting from 5 inches to 10, 11 and even 16 inches. However, one thing to keep in mind is that the bigger the aperture, the more magnifying power you have on your telescope. However, this also means that the telescope is in much big shape and size, which means that the telescope is much more heavy. So stay sharp and keep an eye on what you want to buy and how you want to use that telescope. Now last but not least is the Cassegrain or catadioptropic telescope. Now these are my favorite telescopes because they use a combination of both lenses and mirrors to magnify and focus the images, which are very bright, very sharp and perfectly clear images. Now these telescopes are very expensive. They come in very huge apertures, mainly from 6 inches to 16 inches, and they're very expensive, so keep that in mind. The Cassegrain is also in two types, the Muxetov Cassegrain and the Schmidt Cassegrain. Both have their very small differences, but they do both the same job, and they're both very expensive. They start from $500 up to $10,000.
Observatories like the one in ancient world are the main place of studying the stars. These observatories include the Mauna Kea Observatory in Hawaii, Alma Observatory in Europe, Yerkes Observatory in Wisconsin, USA, and the South Pole Telescope, which is obviously located in the South Pole.
But not all telescopes are these small apertures and ground-based.
Since air causes a disturbance in the incoming light rays from the distant objects, ground-based telescopes find it hard to clearly view distant and faint objects in the sky. And that is where space comes in. If you leave Earth's atmosphere and go to space, you will find a vacuum with no air, hence no air resistance, which means light from objects are as clear as you want it, unless another object bends the light rays before it comes to you. Therefore, many nations and agencies send space-based telescopes embedded in satellites, which are sent to space for research and development. Examples of these are the Hubble Space Telescope, Kepler Space Telescope, or the soon-to-be-sent, the magnificent James Webb Space Telescope. When launched in 2019, James Webb Space Telescope will be the most powerful space telescope in the world.
So as we can see, astronomy and telescopes came from a very long way, from Muslim scholars in the 6th century AD to people who got executed for speaking up their minds. But most importantly, telescopes are a gift from the heavens. So we could look up in the sky and watch the beauty and the chaos of the universe. Telescopes are very powerful. They can make you laugh, they can make you cry, or they can make you fall in love with the sky. And many people around the world does the same. They take out their telescopes in the streets and they let other people look into their telescopes and watch the skies. And they might have influenced lives of many people. Thank you very much for watching this episode. Please share your ideas in the comment section down below, add a like, and don't forget to subscribe for more videos.